So now in theory, you run your AI behaves intelligently and everything's happy. Whenever it doesn't, 90% of the time, that's because somebody screwed up in their deep copy. So usually just bashing that out will get it right. But what if it doesn't? How do we debug this thing? That's the real question I want to answer today. Okay, and now that I'm finally to my main point, let's make the main point. How do you debug this thing? Let's suppose that your game looks like this, and tell me if this isn't exactly what your situation is. You've got a tube, you've got a Mario, your AI says go, and Mario runs up to the tube and then sits right there, running into the tube and doesn't bother to jump. Is that what's happening? Well, let's pretend it is, because that's the one that seems to come up the most. Okay. This is not intelligent. An intelligent AI would go boing and hop on down, and then it would see the Goomba sitting right over here and would shoot the Goomba. Everything squares in my world. And the Goomba would catch on fire, which I'll represent with a yellow square because now it's funny. And okay, intelligence has occurred.
I have to speed up how quickly my Goomba's done because mine didn't look forward that much. Is that okay? Like I had like
yeah.
85 frames in my original game, and I was like 5 frames.
Okay. I'm actually really content with any hacking you want to do to appease your AI. So feel free to do that. Your Mario should be able to get kind of close to the Goomba, and as soon as it gets close enough that the Goomba is within its horizon of foresight, as soon as it can see that there's a Goomba out there, it should know that shooting it is a good idea. Although it might recognize that if it delays a little bit, then it can delay getting that penalty. But it should be able to run right up and shoot the Goomba just at the nick of time, I think. Yeah.
What if Mario jumps after a few tubes and then decides not to jump after another tube?
I don't know what would cause that. If it jumps over the first few tubes, that kind of suggests it's working. Let me give you the quick solution. Just delete the tube he doesn't jump over and turn it in. I know that's kind of hack, but the right answer, of course, is debug it. If it works on one, why would it work on the other? Basically, the thing is we've got to figure out what's different, right? And so it's going to come down to look at the code and see what's different. There is some programmatic reason why he's not jumping over the next one. And it's a matter of examining all the variables and seeing what's different in the second condition. Okay, so here's why Mario's not jumping over your first tube. It's got to be right here in your code. Evaluate the actions. He's tried running, he's tried run and jump, and he's tried run and shoot. And here it says do the best one, right? If run and shoot is better than run and jump and run and shoot, then he's going to do run and shoot. So if he's always choosing to just run, it must be true that run is getting the best score, right? Or they're all the same. One of those two is happening, and I bet you the condition is that they're all the same, right? And hopefully you've looked at that by now. If you haven't, look at that. Put a breakpoint right here. Check what happens to all the scores. If they're all the same, then we need to ask the question, why are they all the same? And why shouldn't they be all the same? And why should they and why aren't they, right? Here's how I would make them work. I'm going to take my tube and I'm going to lower it down to right like there. This is a 1 pixel high tube. And I'm going to start my game with Mario right there because I don't even want to wait 1 frame till he runs up to the tube. I want my game to begin right in this situation. Why? Because it's easy, right? At this point, if Mario continues to run, his toe will be stopped by this tube. That's stupid, right? Okay, but if he jumps, within 1 frame, he'll be higher than that tube. And so clearly he should go to the right. And therefore, if I were debugging this thing, I would expect that the score of run should be the score of just standing where you are, and the score of run and jump should be go up a little and go over a little and that's better, right? Why is that better? Because this is how we evaluate the game, right? Mario posts, and by Mario posts I mean model.mario.x or whatever variable you use to represent the scroll position. I am seeing a lot of students creating a new variable called Mario posts, and I'm sorry, I don't know how to express myself well sometimes. This is just pseudocode. Don't just copy my code and expect it to be correct for your situation. My variables won't match yours, etc. This means the position of Mario in the model of the game, the scroll position of the camera. Yeah.
I also did it where I added a new one called Mario Dead, where in the copy, like the copy evaluation, if he ever ran into a Goomba and should have died, I made it like minus 10,000 points, because I found that if I didn't do that, he would just run straight into a Goomba and kill himself.
Ah, okay.
Yeah.
Yep. Thank you for understanding it well enough to hack up the heuristic. That's exactly what I want. So I don't care if you mess with it. In fact, I hope you do mess with it, because that really shows you've owned the code. So no shame in that. Presumably your Mario moves at about 10 pixels per frame, right? Is anybody moving at 1 pixel per frame? 5? Cool. It's probably 5, 10, 15, 20-ish. If you're going less than that, that's a really slow Mario, right? I mean, you just don't want it to be painfully slow. Do you see how there's a penalty of one for every time Mario jumps? This jump count is implying the number of times you've jumped. Well, if you've jumped, there's 1 penalty. And if you only move 1 frame, basically you get 1 penalty and 1 benefit for jumping. You see how that just evens out? That's kind of no good. So you'll have to double his position here if you're going to move 1 pixel at a time. But in most cases, I bet you're moving 5, 10 pixels per frame. So if you get, which is better? Sitting there, running into a tube and not gaining any ground and not jumping, or jumping and losing 1 penalty point and gaining 10 points of position reward? Let me ask it another way. Would you rather have 10 donuts and a slap on the hand, or nothing? Depends how hard you slap me on the hand. I slapped you exactly 1 donut worth on the hand. The point is, it's better to jump and run than it is to not jump at all if you're moving more than 1 pixel per time. Do you see that? You get the heuristic here? Okay, so here's how you debug it. You put a breakpoint, say, right here. And then you step into your evaluate action function, which steps into right here. And the first time the depth is not deep enough, so we're going to actually come down here and do an action. And the action we'll do is, the first time it's just run, right? And when he runs, he'll go into the tube, but then he'll get pushed back out of the tube. I mean pipe, whatever we call it now. And then it'll recurse. And when it recurses, it'll go to the depth of D. And then we'll evaluate this heuristic. And we'll say, hey, you've made no progress, but you have jumped. So you're even worse off than, oh wait, no, you didn't jump. You've made no progress, so your heuristic is, I don't know, 72. Then we'll step out and we'll try the next one, run and jump. And we'll step in and it'll go into here and we'll do the action of jump. And this time it'll cause Mario's vertical position to go up, right? And this time there's no tube in the way. And so when Mario moves horizontally, he'll succeed. And when we get to this evaluating the leaf of the future, his position will be 10 greater, but he will have jumped 1 more time. So you have a net benefit of about 9, and therefore this number will be higher. And because that number is higher, he will choose to do the one that says jump, and therefore you see why it jumps, right? So here's the important question. Do you understand why Mario should jump? Okay. Yeah, the reason he should jump is because if he jumps, he gets paid back right there. If you understand why Mario should jump, can you debug why he's not jumping? And the answer is, well, you put a breakpoint right here, and you step through, and you see how what he does differs from what he should do. And as soon as you find that point, you have solved your problem. Any questions on how to do that? let me give you another tip. We have these two variables, k and d. Are those boggling your mind? Do you know what they do? Okay, let's suppose d is 12 and k is 3. What's going to happen? Every 3 frames, we're going to try all 3 actions. So 4 times we'll try all 3 actions, which means 3 to the 4th power is 3 times 3 times 3 times 3, which is 9, 27, 81, right? How much would you enjoy stepping through this code 81 times? Big pain, right? Well, that's exactly why I pushed my tube all the way down to just 1 pixel high. Because if I push my tube down to 1 pixel high, then I can come in here and I can set d to be 1. And I can set k to be 1. And now it's only going to look ahead 1 step into the future. You see that? And if I only look ahead 1 step into the future, well, now I only have to debug 3 times through evaluate action rather than 81 times through evaluate action. So, hey, it's totally okay to manipulate the variables to make your life easier to debug. And in fact, it's not only okay, that's the grand secret to debugging. Often your bugs will be so impossible to find that your head will explode if you try to chase your bugs. So what do? You create a situation, you push your tube down to 1 pixel high, you muck with your variables, you create the perfectly super simple situation where your bug is happening right now. And then you step through and see the bug happen, and then you say, oh, that's why it's happening, and then you fix it, and then the bug is gone. Then you put everything back, and now your code is fixed. Yes, it's a pain, but that's kind of how you have to do it. That make sense? Okay, so let's talk through d and k. If d is 2 and k is 1, this is what your branching looks like. And you can imagine yourself stepping through each of those nodes in that tree is one call to evaluate action, right? Okay. If d is 20 and k is 20, what does that look like? Like that. Pretend there's exactly 20 depth there. Do you see how, which one of these is going to be easier to debug? Yeah, well, in the top one, in fact, you're going to have to visit these 9 futures and these 3 intermediate ones, and this one, that's 9, 10, 11, 12, 13 total passes through evaluate action. In this one, well, let's see, let me put it this way. It depends what you're looking at. So in this one, there are actually 9 leaf nodes, right? In this one, there are actually 3 leaf nodes. So what problem are you trying to solve? Let's suppose you're trying to see what the final future looks like. Do you see how this is the leaf? Right here, when we reach depth is greater than or equal to d, this heuristic evaluation, this is when you've reached the end. So if you were to put a breakpoint right here, because you want to see what the future holds for different actions, then the number of times it'll hit that breakpoint is 3 for the bottom one and 9 for the top one. Do you follow that? Okay, so let's now suppose you've got Mario jumping over the 1 pixel high tube, but Mario for some reason doesn't jump over the 50 pixel high tube, and you want to debug that. Here's how I would do it. So Mario just won't jump over the darn tube, and I want to know why. What do? I'm going to come in here and I'm going to set d equals 10, or however many frames it's going to take Mario to get over that tube, right? Let's suppose I study my code and I realize, okay, he goes up that far, and then that far, and that far, and then that far, and then that far, each time he's jumping. That was about 6, right? Okay, let's suppose that was 6. So I'm going to come here and set d to be 7 or 8. Because that means I'm looking far enough ahead that I know I'm going to clear the tube. And then I'm going to set k to be what? I'm going to set it to be the same as D, because that means that we're going to have one of these type situations where I'm only going to branch at the very first time, and thereafter I'm going to not do any branching. And so I'm really testing what is the future if I jump and then run, 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 run. What's the future if I just run, 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 run? And what's the future if I throw a fireball and then run, 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 right? Presumably, the one where I first jump and then run, 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 run is going to be the best future, right? Because here I am in this situation where Mario should jump and then momentum will carry him up, and I finally see the future right here. And in that future, you see how Mario has moved forward and he gets a better reward. Therefore, way down here in the past, Mario should jump. So the way I'm going to debug that is I will put my breakpoint right here on this heuristic line. I'll set my D to be really large so I can see far into the future. I'll set my K to be equal to D so I have exactly this type of long stretched out situation. And then I'll test what my three positions are. If it's not working, it's probably because these three numbers are computing the same. And that probably means that in the copied model, Mario position is still stuck behind the tube. And why is he still stuck behind the tube? Well, if you step in, you'll find out why. And it's probably because you didn't deep copy your tube properly and it's still remembering the old tube, or Mario's not going where he thinks he's going. Bad things are happening in your code and you have to chase it down and then fix it. Does that make sense? So I claim that just by answering the question, why is Mario not getting more farther ahead by jumping, you will solve the problem of why is Mario not jumping? Because if he gets farther ahead, he gets a better score, and if he gets a better score, that's the action he chooses. So that's really what you got to do is step through. It'll end up going through your copy.do action function, because this is where it actually happens, right? This is what makes Mario do his thing, and that should affect your model in an intelligent way, and you got to go look at your variables.